So you don't need to write all this down yet. It'll be emailed, it'll be on the website. We'll be going back and forth during the class right now with this. But let's go to, remember, each group of problems is a little bit different and similar to something different on the test. So you want to try some from each one. So the first page, from page 120, 17 to 34, if you look in your book, 17 to 24, that is, where is that at? That's there. Okay, 17, and I just cut it off at 24. I don't even know why I did that. Oh, maybe it says 34. Yeah, it says 34. Okay. So remember, this is where we got quadratic functions that were not in the standard form. Okay, what did we mean by the standard form? You're missing something. Squared, right? So we want to be able to put it in the a times x minus h squared plus k form. So for example, if we should take one that has just a little more to do with it. How about, I hate to do ones that have too much, but let's try the number 31, okay? 4x squared minus 4x plus 21. Right, how is it that we put that into the standard form? Remember, you had two ways, right? You could do the negative b over 2a, all right? We're aiming for this thing here. F of x equals a times x minus h squared plus k. So you could do this. You could say h equals negative 4 over 2 times 4, which is 4 over 8, which is 1/2. Okay, and then you can plug that in here and here and find the k. Right, so k equals 4 times 1/2 squared minus 4 times 1/2 plus 21. So this is 4 times 1/4 minus 2 plus 21. Right, which is 1 minus 2 plus 21, which is 20. So in this form, we've already figured out the h is 1/2, the k is 20. The only thing left to add is the a. Where do we get the a from? It's the same a. It's right there. So here's the formula. F of x equals 4 times x minus 1/2 squared plus 20. Right? How else could you have done it? Complete the square, right? If you complete the square, it would have worked like this, right? We would have said f of x equals, and we would have factored the 4, since it's a number other than 1. We would have factored it from the first two terms. We would have left a blank and put the 21 outside. Okay, how do we figure out what goes in that last spot? Half of the middle term is negative 1/2, right? Squared is 1/4, right? So that is plus 1/4. Okay, but if I add a 4th there, I got to do something to compensate. Yeah, are we subtracting a 4th? No, we're subtracting 4 times the 4th, which is 1. So minus 1. So this is f of x equals 4 times. Okay, now remember, this is something we wouldn't look at and readily factor. But remember, what's in the parentheses, it's always x, plus or minus whatever that half of the middle term was. So since it was a minus 1/2, this is minus 1/2 squared, and 21 minus 1 is 1. Same thing. My guess is you would probably think that's easier. But you need to show one or the other, right? Do not just go to your calculator and find the minimum and say, okay, that's my vertex. Right? You're not going to get the same credit for doing that as doing algebraically, find it. Okay. That we are there already. PC. Okay, 47 to 56. 47 to 56 must be on the next page. Yes. Okay, remember these problems? Find the equation in standard form if you know the vertex and 1 point. So let's grab one. How about 4, negative 1, 2, 3? Okay, 4, negative 1, 2. The vertex is 4, negative 1. The point is 2, 3. Okay, so we're trying to fill up this thing right here. F of x equals a times x minus h squared plus k. Okay, so we need to fill in for the a and the h and the k. Okay, well, we've got 2 of the 3 we know already, right? 4, negative 1, hk. So that's this. F of x is a times x minus 4 squared minus 1. And then how are we supposed to find the a? Plug in the x, y, right? The x goes here, and the y goes in the place of f of x. 3 equals a times 2 minus 4 squared minus 1. 3 equals 2 minus 4 is negative 2. Negative 2 squared is 4, so that's 4a minus 1. Add 1. Divide by 4. So a equals 1. So here's the final version. F of x equals x minus 4 squared minus 1. Just fill in for the a. Okay. Okay, the next 76 to 80. So the 76 through 80 are all word problems that involve a maximum or minimum. They're asking you for what is a maximum, what is a minimum, okay? Considering the kind of function we're dealing with, what is it they're asking us for when they're asking us for the maximum or the minimum of a quadratic function? The vertex. And how do you find the vertex? I mean, again, you could do completing the square on this, but I doubt you would want to do that. Okay, factor out negative 16 over 225 from those two terms. What's the other way? Negative b over 2a. Right? Just do the negative b over 2a, plug it back in, find the k. There's your minimum or maximum. Right? So there's like 76 to 80 are all some version of maximum, minimum word problems. So when you're asked for that, you know what you're looking for. Next. Then we jump to the next page, 144, 11 to 24. That was wrong. Okay, that's right. Okay. So that's long division, right? There'll be just one that says do a long division. That's it. When you're doing long division, I mean, it works just like long division with numbers, but in terms of the polynomials, what is it you have to be careful of? Like in something like this number 17, where it says x to the third minus 27. fill in missing powers of x with zero coefficient terms, right? So you would be writing down inside the divide symbol, x to the third plus 0x squared plus 0x minus 27. Right? Make sure there's a placeholder for each one. And actually, even on something like, look at number 21, you would have to fill in for the x squared and the x, and even the thing you're dividing by, x squared plus 1, is missing the x. Fill in with a missing power of x with a 0. All right, I think besides that, pretty straightforward. The next, 59 to 66. Okay. Basically, this is a way of saying synthetic division. You don't have, like, just a problem says, divide using synthetic division. But you do have something that says reduce a polynomial from a fourth degree polynomial to a second degree polynomial using these two zeros. And this is like the closest thing that I could find for that. So again, synthetic division, you got to set it up correctly, right? First, you're going to write the coefficients of what you're dividing. Let's see. This one, 48, negative 80, 41, negative 6. Right? What number do you put in the bracket on the other side? The 0. Whatever is the 0. In this case, it's 2/3. Right? Not negative 2/3. That would be like if they gave you the factor x minus 2/3. Then you would put in positive 2/3 because it says x minus 2/3. Right? And then you bring down the first coefficient and you run with it. Same. You still have to fill in the missing powers of x with a 0. And make sure, you know, you got to turn it into a polynomial like we saw in the quiz. Then turn it back into a polynomial. Don't just leave it as the coefficients. Okay. 152. 51 to 60. So this section was the complex numbers. So the 51 to 60, just like we did on the quiz, you know, it'll be a divide. Put this quotient into standard form. How are you going to do that? Multiply by the conjugate. Since I didn't do it in the one, how about I'll take 5 plus I over 5 minus I. We'll do that one. Right. Oh, that's wrong. So what do I multiply by? 5 plus I over 5 plus I. Okay. So in the numerator, that's a FOIL, right? 5 times 5, 25, plus 5I, plus 5I. And what do you get when you multiply I times I? We're going to get plus I squared, right? And then in the denominator, right, when you multiply complex number times its conjugate, it's a FOIL, but the middle terms cancel each other out. So it's just 5 times 5, 25, and then minus I times plus I will be minus I squared. So this is 25 plus 10I minus 1 over 25 plus 1. So 24 plus 10I divided by 26. And then you could simplify that, right? Everything divisible by 2. So if you factor the 2 out, you'd have 12 plus 5I divided by 13. Which if you were really being careful, you would say 12 over 13 plus 5 over 13 because that's A plus BI. But if you did that, I would be happy with that. You know, this is the main thing. You know, if I see you didn't even do that part, then there won't be any credit if you didn't start it right. I mean, there's not much to grade then. Okay, let's see. We are at that was the only thing on the just complex number operations. 164.15. Okay, so there will be something on the test that says list the possible rational zeros. Right? Remember, how do we come up with a list of the possible rational zeros? Right? The factors of the last term divided by the factors of the first coefficient. Are any of these interesting? How about this 18 right there? So let's see. This would be, let me do it like this. We good? It would be the factors of -2 divided by the factors of 4. Okay, but the factors of 2 are plus or minus 1, plus or minus 2. Remember, it's always plus or minus. And the factors of 4 are 1, 2, and 4. And now you have to take all the combinations of what's in the numerator divided by what's in the denominator. So it'll be 1, 1/2, 1/4. And then it'll be 2 over 1, which is 2. 2 over 2, but you already have 1, so you don't have to do that. And 2 over 4, which is 1/2, but you already have it there. So this is the list of possible rational zeros. Now, is it possible that they're all zeros? I mean, this one has how many zeros? It has 5 zeros, right? So this is 1, 2, 3, 4. That's 8 different zeros. They can't all be right. So there may be almost none. Well, they've given us the graph. How many are there? 1, 2, 3, 4, 5. They're all real numbers, and they should all look like -1's in the list, -1/2 is in the list, +1/2 is in the list, 1 is in the list, 2 is in the list. There you go. So they match up. No. You're just going to be asked for the list of possible rational zeros. Okay. What happened to my... Oh, I know. That's what happened. 37 to 40. And we're going to go to the next page. 37 to 40. Okay, and this, you know, it's all kind of like common. I think what you're really asked to do is find all the real zeros. So list the possible rational zeros. Okay, that was part of a different problem. And then it says it's okay at that point. Once you've got your possible rational zeros, use the calculator and figure out which are the ones that are probably the zeros. And then, you know, find all the zeros. So how do you use the zeros that you've got to find all the zeros? By doing synthetic division, right? Somehow. I mean, let's try one of these because this is pretty important how it works. How about let's try, I don't even know how it's going to work out, but let's try this one here. The possible rational zeros are the factors of 18 over the factors of 4. Okay. Let's put it in the calculator. 4x to the third minus plus 7x squared minus 11x minus 18. Okay, graph. Okay, how many zeros do we see? We see 3 of them, right? And it's kind of hard to see. Let's go to the table of values. I'm on the so let's see if any of them show up. There, the -2 is in there. But you could see, okay, there's another one between 1 and 2 because of the intermediate value theorem. And there's another one. I might have missed it. Yeah, I probably did. Oh, there's another one between 1 and 2 right there. Maybe that's, okay. So anyways, we definitely know we have one at -2. So let's reduce this polynomial to a quadratic so we can find the ones that are left. They're real numbers, right? But they may not be rational numbers. You know, they may be something you're going to have square root in, something like that. So 4, 7, -11, and -18. And we said the zero is at -2. So we go -2 times 4 is -8. -2 times -1 is 2. -2 times -9 is 18, 0. Okay? So these are the coefficients of a polynomial of 1 less degree. And let's see, is it factorable? I mean, can you think of factors of -36 that add up to -1? No. I mean, you'd have to go, you got 6 times 6, and then you'd have to have like one number apart so that it added to give you -1. That's not going to work. So how do you find the last two? Quadratic formula, right? So you would have to go in and say x equals -1 plus or minus the square root of -1 squared minus 4 times 4 times 9. Actually, -9 divided by 2 times 4. 1 plus or minus the square root of, right? 16 times 9 is 144. So it's 144 plus 144 plus 1. It's 145. And can you simplify that? 5 times 29 now. It doesn't have any perfect square factors, so that's simple as it gets. I mean, that's why you've got to be able to reduce using what you know, because your last two answers may end up being either they're imaginary, which clearly wouldn't show up in the graph, or they're irrational, which means the only way to get them is by doing this. Okay. That was the 37 to 40, and then 45 to 50. Okay. How do you turn zeros into a polynomial? Say again? You turn them into linear factors, and then you multiply the linear factors. So let's say we're going to do 48, right? Most of the time you get this problem, they're not giving you all the zeros, right? Like this one here, 5, 3 minus 2i, there's at least one more there. What is it? 3 plus 2i, right? Because we know imaginary numbers occur in conjugate pairs. So we would have to go 5, 3 minus 2i, right? And then we have to add the 3 plus 2i because we know it's there. And then what? make them linear factors by doing x minus in front of them. Right? X minus 3 minus 2i. X minus 3 plus 2i. Okay, and then what? Multiply them, right? Now, which two are you going to multiply first? Yeah, you always multiply the two imaginaries first because that'll make all the i's disappear. You don't want to do these two because then you wouldn't get them all to disappear. You could be fun to try. Well, you may not think it was fun to try, but you could do that and see whether you could get everything to cancel in the end. So yeah, make sure to multiply these two first, and then whatever you get there, multiply times that. And remember, we did this kind of a table. The book did it a slightly different. I think I ended up showing 3 different ways you could do that. But if you're okay with the table, just use the table. And just be very systematic about it. Remember that all the I terms are going to drop out. Right? It's always like this one cancels with this one, and this one cancels with this one, every time. So it ends up just being these 5. So I'm not going to do it just because we'll run out of time. Okay, next. That was the last on that page. Now we get to page 177, which is probably, yeah, the thing we had in homework last night. So that was 177, 17 to 40, 49 to 62. Which essentially it's the homework problems we did last night. You know, be able to graph a rational function. You know, find the intercepts, find the asymptotes, plot a few points, sketch in the graph. Right? There will be something to graph the entire thing. Right? The next set of problems, which was 49 to 62. Right, that's these problems here. Remember, the difference with these problems was that you had slant asymptotes, right? And what I said in the study guide is just 49 to 62 C. Only the part that is calculated of slant asymptote. You don't have to do the whole graph. It's just going to say, here's a rational function, find the slant asymptote. Right? And how are you going to find the slant asymptote? You're going to divide, right? Polynomial long division. Because most of the time not most of the time, but some of the time the denominators are not linear factors, so you really have to do it with long division. So, you know, if you don't see something in there that we did during the chapter, it's because it's not on the test. So focus on this stuff here. Again, this is a study guide. It's for extra credits to be handed in before the test. You don't have to do every problem, but you should do some in each group because they're different. You know, I give full credit, you know, fairly liberal, but when I see whole pages that weren't even touched, or pages where you just write down the problem, but you don't actually do anything, you know, you're not going to get the full credit. If you happen to fail and you want to retest, you must have done the study guide and gotten the full credit. So don't tempt fate by seeing how little you can get away with. Remember, you're supposed to be doing the problems, checking your answers where you can, trying to fix what you don't get right the first time. And if you absolutely can't, then come see me. I'm here all the time. I mean, there's plenty of chance to ask a question. Remember, we got the videos online. Remember, we've got right on the front of your book, you've got the LarsonPrecalculus.com website. There you can get all the answers to the odd numbers worked out. You can supposedly chat with a tutor. You got a lot of options. But, you know, bottom line, you got to take some time and prepare for the test. So, any questions about Test Tuesday? Okay.